Hello and welcome to the Discover History YouTube channel, and tonight we're going to take a look at some more navigational equipment. If you are watching this in the playlist, you will find this under Mayflower 400, and there's a reason for that, because this year in 2020 we are, or should be, celebrating the sailing of the Mayflower. And as I've said numerous times before, Worcestershire, our home county, is linked to everything. Some people say it's linked to all the great events in the history of Britain. We are. But we can also say we are linked to, in many cases, to international world history events as well. And this is a perfect example of this. Edward Winslow, born in Droitwich, schooled at the King's School in Worcester at the Cathedral, later went on to be a printer, and even sailed with the Pilgrims to the Americas. And he's a leading character. He's a character that set up numerous treaties and pacts with the native people over there. He was also one that documented the first Thanksgiving meal that the Americans are always celebrating later in the year, in the autumn, in the winter months, I should say. Edward Winslow is also the only person to actually have a painting of himself taken in real life as such. Really, we do have numerous paintings of the Pilgrim Fathers as such. The only problem is a lot of them are painted after their death, when they're being celebrated for them setting up the Mayflower generation as such, really, in the Americas. However, Edward Winslow had a painting, a portrait painted of him at the time, so it makes him a very significant character in that way. If you look at Edward Winslow, straight away you will be drawn to his portrait, the only one taken when he was alive during this famous period in 1620. Anyway, we've been doing several videos on not just about the Mayflower, the ship, or how they colonised that part of America. The most fascinating bit that I find is the actual journey from either Holland to Britain, or more importantly from Britain across to the Americas. And if you look through the playlist that we have for Mayflower 400, you will see we've done a video on the binnacle compass and also the lodestone used to magnetize that compass, one of many that would have been on board the ship. We also looked at the chip line, or the ship's reel, or the ship's log as it's sometimes called, for checking speed. We also took a look at the traverse board for recording that down, and also the sound, which was for checking the depth of the water below the ship. So there was a lot of navigational tools, and I find them absolutely fascinating, of how people got from one place to another without any proper maps as such as we have today, or more importantly without the GPS system that we have in the sky. So tonight we're looking at latitude, and latitude is knowing where you are on the Earth's surface. So if you can imagine the globe in front of me, the Earth there, the main line that navigators use is the one in the centre, that's the equator. And to work out the latitude, in other words, how far north of that or how far south of that in the southern hemisphere you are, you need to take a reading from a celestial body. Now, this can be done at night, on a fantastic clear night on board a ship. You can look for the plough as such, the famous star constellation that goes down, often referred to also as like a frying pan. And if you take the two edges of that and go directly up, you will find the Polaris, or the pole star, the north, and the North Star. You need to take a reading of that at the height it is off the Earth, or more importantly, and the most common one, is you take a reading of the sun at midday. Now, the problem with that is, whilst you're at sea, you could not always guarantee getting midday, not accurately anyway, until you get more accurate clocks later on. it's a bit of guesswork. And what you have to remember, as we mentioned in a previous video, there is always a watch on board a ship as such. And we're not talking about a watch on your arm, we're talking about the ship's watch. In other words, a body of men on duty at a given time. And they have to wait every 30 minutes. There will be a bell rung to say, that's the first 30 minutes, the second 30 minutes. So if you're trying to work out the time, your ship sailed at, let's say, 3 o'clock in the afternoon on Friday, you are having to rely on that hourglass, that sand timer being turned over constantly, keeping that record of time. So the problem is, this isn't going to be the most accurate way of telling where you are. You can't tell where you are using this method on its own. You have to use it with all the others. So you're using your compass, you're taking the depth soundings, and remember, you'll also get an idea of what the seabed is like from the fat that you put in the bottom of that, your speed. You're using all these things in conjunction. You will not get any accurate navigation if you just use one or the other. Even a compass on its own really would just tell you the direction you're going in. You have to use a collection of navigational instruments basically. Nowadays, a press of a button even on your phone will tell you where you are. So they actually use two devices to find out the latitude of your ship, whereabouts it is on the earth, using the sun or the North Star. There are a number of devices that could be used. There was things like the astrolabe, there was also the backstaff, but the one I use, the one that I've got here, is actually quite an ancient form, and it's known as a mariner's quadrant, and it actually dates back to the ancient Greeks. We know the ancient Greeks were using these as well, and what it actually is a quadrant. So it's a quarter of a circle, and this one's made out of wood. Some of these were actually made out of metal as well, for example brass or bronze, and some of them actually have sights on, either set at the top or set in the side. The most basic ones, as we have here, doesn't have that. So what you have to do is line this beam up with the sun at midday, and that will give you the angle it is in relation to the earth, in other words to where your ship is. So what you actually do is you take this quarter, this quadrant, you place your eye down at this end, and you're going to look up the beam lining up with the sun at midday, as I mentioned. You do have a plumb line on it, as you can see, a very ancient way of making sure that the device is taking an accurate reading, an accurate angle, and it needs to be free flowing. Now sometimes this was done by one individual, and he will line it all up and hold it, pinch it, and then take a reading. Or we definitely know it could be done with 2 or 3 people as well. In other words, you could have someone stood where the camera is pointing and will tell me what the reading is. So remember, this is latitude only. Where are we, north or south of that equator? And it has to be measured at around about or exactly 12 midday. Now you will foresee a problem here. You can't accurately tell time. That's one problem. The other problem is a ship is very rarely flat, calm on a sea. Usually there is a certain amount of movement which will make this unbelievably difficult. You've got to take your hat off to the navigators of the past. So I will do a quick demonstration. If I use, for example, the lampshade, for example, that's my sun. I've been told now it's midday, so I'm going to take a reading. I therefore place my eye along the quadrant here, and I need to aim right at that sun. You can imagine the problem that you're going to have when it's cloudy, or worse than that really, I always say, is the problem you're going to get when it's really sunny, because what you're doing is staring directly at the sun. You can imagine the amount of mariners that went blind from doing this over a long period of time. The other devices that I mentioned, like the backstaff or the astrolabe, that usually uses some discs and a plate, and therefore you just line it up so the sun goes straight through the holes onto the plate, and then you know you've got the direct line of the sun. The brighter it is, the more likely it's an accurate aim at the sun. But if you do it that way, as I said, very, very dangerous. Do not stare at the sun at any point in your entire life. If it's at night and you're looking for that northern star as such, that would be safer. But like I said, it's a rocking and moving ship. Very difficult task to do. And basically, you're taking the angle that that star or that sun is in relation to the ground at midday. So it could be up there or it could be down there, and you're reading it off. For example, it might be 24 degrees north, in other words 24 degrees north of the equator. However, the problem is, as we know, and they had a certain understanding of this as well, the Earth doesn't just spin around. There is a number of things going on. It tilts, for example, and therefore you couldn't use that on its own to be accurate. You needed a declination table. So on board your ship, you would have a little book like this one, and it would have tables in it for each month, and it'll be a very complicated calculation telling you what calculation you have to add to that to make an accurate reading. And that will give you an idea of where you are on that globe at any one time, your latitude, as we still call it today. So hopefully that has all sunk in. There is no test with this whatsoever, but this is probably one of the more complicated systems used in navigation. Your compass gives you direction. You've got your chip log, your reel, your log line, your ship's log. That will give you your speed. So you've got your direction and speed. You're taking extra readings like what's on the seabed, what depth of the water, and now you've got the latitude. Where is the sun at midday, or maybe later in the evening, where is that star? And that will all, when it all comes together, help you to navigate from one place to another. But remember, we haven't finished yet. There are other navigable tools or instruments that we need to look at before we finish how the Mayflower sailed from Britain to America. Anyway, on that note, hope you've had a fantastic weekend, and we'll see you tomorrow. Bye bye.